Hello, beautiful people. This is Miss Beeching here. I'm going to explain today how to look at parallel and perpendicular lines, especially when it comes to the equations for those lines. Now, you've probably seen both of these types of words before in geometry, and they mean the same thing here when it comes to graphs. We're just going to have a look at what that means in terms of their equations and especially the gradient. So just like in geometry, a parallel line has the same slope or angle, and you can see that here in this picture. And that means that they also have the same gradient, which you can see here. So we're saying that the gradient of the first line, M1, so we could call this line line 1, and we could say that the equation's like y equals m1x plus c. Okay, and if we say that this is line 2, the equation could be y equals m2x plus c. So the M1 and the M2 just mean that it's line 1 and line 2. So they have the same M because they have the same gradient. And that fact's going to be really useful for finding equations. And as you might have noticed with these lines, they never intercept. So these two lines will never cross. It's like the friend zone. You're never going to get out of it. You're never going to get to touch the other line. How sad. Now, if we go to perpendicular lines, this is almost like the opposite. So these two lines are at 90 degrees to each other, or a right angle, and they look like this. And the gradient is the opposite because these lines are facing in as different directions as possible. They've got opposite gradients. And so that means that the gradient is the reciprocal of the other line's gradient. And you might remember reciprocals from fractions where it's the opposite. It's 1 over the other number. And you can see that here, the first line is the negative reciprocal 1 over the gradient of the other line. And the negative is just there because the lines are facing in different directions. Remember that a line that goes up is positive and a line that goes down is negative. So that's why that negative jumps in. And the reason for the reciprocal is just because the line is the opposite direction. Okay, now I'm going to show you a few examples of parallel and perpendicular lines, and then I'm going to show you how to find the equation for them. So you can see in this example, I've got these three lines here in blue, red, and green. And the equation for each of those lines is in the matching color. So this blue line has the equation 2x plus 8. This red line has the equation 2x plus 4. And the green line has the equation 2x minus 4. Now you might notice that these lines are parallel. And you also might notice that these lines have the same gradient. All of them have a gradient of 2. So all of these lines are parallel and they all have the same gradient. That one's pretty straightforward. Perpendicular lines are a little trickier. So in this example, we've got the green line as negative 1 on 4x plus 2, and the blue line is 4x minus 8. Now you should notice here that the blue line and the green line are negative reciprocals of each other. So the blue line has a gradient of 4 and the green line has a gradient of negative 1 over 4, the negative reciprocal. Okay, add the words down there. Now let's actually try to practice finding some equations for these lines. All right, so I've got two example questions here. Both of them are pretty similar. Both of them we're going to be finding the equation for a line that relates to this line here, y equals 3x plus 5. And both of the lines are going to go through the point negative 5, 7. Now be careful here. This means that the parallel line or the perpendicular line will pass through this point, not this equation here. Okay, so we're trying to find the parallel line that's parallel to this and passes through this point. And then in the second one, it's the same thing, but we're going to find the perpendicular line. So let's do the parallel one first. In this situation, we're first going to find the gradient. Now the original line had a gradient of 3. That means that the parallel line will also have a gradient of 3. So that's nice and straightforward. So m equals 3. And we know from previous skills that the equation for a straight line in like a general form is y equals mx plus c, where the m is our gradient and the c is the y-intercept. We don't know the y-intercept, we only know this point here. So what we're actually going to do is sub this point into the equation as well as our gradient, and then find the missing c to get the final equation. So let's give that a go. I'm first going to write it like this, y equals 3x plus c, and then I'm going to sub this point into that equation. And I'm going to label the numbers that I'm subbing in with a different color. So in this point, y equals 7, and then we can put in that 3 again, and our x is negative 5, and we still don't know what c is, so we're still going to write plus c. Now let's simplify this down a bit. So 7 equals negative 15 plus c. And now we just need to move this negative 15 over to the other side of the equation so that we can get c by itself. So we're taking away 15, so we're going to add it to both sides of the equation to move it over to the other side. 7 plus 15 is 22, so that means our c is 22. So now that we know the gradient and we know our plus c, we can find the whole equation. So we can say, all right, well, it's y equals 3x plus 22. And that is our final answer. That is the line that is parallel to this line and also passes through this point. And you could sub these points back in just to double check. I'm not going to do that in the interest of time, but you can sub it back in to check your answer's correct. All right, moving on. Perpendicular line. We're going to do something really similar again, but our gradient's going to be a bit different, which means our plus c is also going to be a bit different. And that kind of makes sense because the line is facing in the completely opposite direction to before. So we should get a very different equation. So let's start off the same way we did last time. We're going to find our gradient. And this time it's perpendicular, so we're going to have to find the negative reciprocal. The original line has a gradient of 3, so the perpendicular line will have a gradient of negative 1 over 3, the negative reciprocal. And now we can follow pretty much the exact same process we did before by subbing into the equation to find c, and then we can get the final answer. So let's do that again. And each time I'm just going to write mx plus c to remind myself of the original form of the equation. I'm going to put in my m. Okay, and then I'm going to take that point again and sub it into the equation. So y equals 7. Don't lose that negative. It's very easy to lose it. Whoop. I don't want to write x, I'm subbing in x. Times negative 5 plus c. So let's multiply this fraction so it's a bit simpler. So we get, if we get negative 1 times negative 5, we get positive 5. So this will become 5 over 3 plus c. And then I need to move it over to the other side of the equation. Now there's a hidden plus here. So if we're adding 5 over 3, to get rid of it, we need to take away 5 over 3 from both sides of the equation. And you'll have to excuse the varying thickness of my pens. I know it will be annoying for some of you. So we're going to say, okay, 7, and I'm going to rewrite that 7 as a fraction because I'm subtracting a fraction. So 7 is the same thing as 21 over 3, and we're taking 5 over 3. It's going to make it easier for me to find our c. So 21 take away 5 gives me 16. So that's my c. And now I can get my final equation. So our original gradient was negative 1 over 3. And our c is 16 over 3. So that is my final equation. Hopefully you found that helpful. If you have any questions, ask your teacher. Otherwise, good luck with the rest of the skill.